So more on stream flows. Tributaries are an important part of rivers because they offer an opportunity for discharge to increase on the rivers. So the volume of water moving through a river tends to increase as we move downstream. And here we kind of see the Columbia River as other rivers like the Snake and the Willamette feed into the Columbia. This line gets thicker and thicker, indicating there's more discharge of water moving through the river. And of course, the big example is the Mississippi River. The Mississippi River drains most of the United States, has all sorts of tributaries flowing into it like the Ohio and the Missouri River, and they're adding to that discharge because more water is being added, and then it's up to the river to move that water downstream until it gets back to the ocean. If we look at what a profile, what the side of a river would look like over time, this is what we tend to see. At first, the river is working on just kind of moving down whatever topography that it's given. But what happens is it's going to move faster over areas that are steeper, like these rapids here and these falls, and it's going to move slower in areas such as these lakes until it gets back to the ocean, to the sea. So what happens over time is these areas that are steep get eroded down, and the areas that are flat, like lakes, they either get filled in or they just don't erode down anymore. So if we started at time 1 and our topographic profile along the stream's run looked like this, over time that would start to smooth out until we get something like this, which is just a smooth line going from the highest part of the stream to the lowest part of the stream, because it's worn away where its velocity is faster, and it's deposited or not worn away where its velocity is slower, and over time it just has a slowly decreasing velocity as it moves all the way down from its highest elevations to its lowest. So by the time it gets to 4, we would call that a graded stream profile. It does not start out as that in the image you're seeing at the top of the land, but over time it's going to be worn down until it looks like a graded stream. So let's look at the stream network on this map. So first of all, we can see that we have a main river here with other streams serving as tributaries and feeding into this. We would expect the discharge to be increasing towards the ocean. And at the beginning of the stream, the highest point where the stream gets to, we call that the head of the stream, or sometimes the source of the stream. And then as it flows down through this rugged terrain, what it's primarily doing in this area is cutting down into the topography. It's eroding things away, and it's cutting things away down into this area here. However, as more of these streams join together and we get a more efficient flow down in this direction, now we're into a relatively flat area down here where the stream no longer can cut down that much because it's close to what we call its ultimate base level. And in this case, it's the ocean. The ultimate base level is where it just doesn't have any energy left. This whole thing is driven by water flowing downhill. But once water mixes in with the ocean water, river water mixes in with the ocean water, it no longer has any energy to cut down. But what it can still do in this area is it can cut back and forth. And that's what we're seeing here. We're seeing these meanders that we'll talk about, and they're kind of eroding back and forth over time down in this area where we have a gentle gradient. So the steeper gradient is up in the mountains where we're eroding downward, and the gentle gradient is in these flatlands closer to ultimate base level, think like Mississippi or Louisiana, where we're eroding from side to side.